All right, ladies and gentlemen, welcome to another test prep live session. I'm Kino with STEMwithKino.com, and who is in the room? Give me a second. Okay, how you doing, Ryan? Tampa. And please hit the like button, guys. Give me a second to get set up here. Can you guys hear me okay? Outstanding. Okay. I'm going to type in my email. You guys can... Type in my email. You guys can... Sorry about that. I didn't have my speaker set up. But we got it secured. That is the email. KIENOTHOMAS@gmail.com. And let's go to the email. Anybody new to the room, I'm here every week, every Friday, 9 to 10, and then 10 to 11 if anybody, my clients, if they need additional help. You must have completed like 2 hours with me during the week, and so in that session, the Google Hangout is free. Just to jump right into the questions, and like I said, I'm going to do a SIFT. I'm going to start focusing on the SIFT. One of the questions that has come up during the debrief is the proper way to take off from a slope. And I'm not sure if I've covered this before, but at any rate, I'm going to cover it now. In the event that you are in a rotary wing aircraft and you're taking off from a slope, I'm going to draw another situation here. So these are two different situations, two different slopes, and the helicopter skids before takeoff will be contacting the slope like this. And actually, I think I've done this before, but hey, we'll do it again. So here's our helicopter. Can you guys see that all right? I'm looking at my backup screen, and the main rotor's not that. Let's see if that's better. That is better. But I've been asked about this question, and that's why I'm covering it again. But it pertains to rotary wing aircraft taking off from a sloped from slope to terrain. And basically, what you would have to do is you would have to get your skids level first before taking off. Don't laugh at my artwork, guys. All right. So this is the starting position, and basically you would advance or raise your collective. So you generate your lift, and you're not going to try to break away real quick, because if you try to break off from a slow position, then you're already going to be going into sideways flight. And when we depart, we want stabilized flight. So what you're going to do is you're going to slightly raise your skid. That's down slope, I guess you would call it. You would raise it so that the helicopter's level, then you would take off. So like 4 times I've talked to like 4 Sith people that have asked me that question, and I told them that I would address it in the live stream this week. So that is the correct response to that question. You know, raise your skid, get the helicopter level first, then take off. Because if you just apply your collective, start producing the thrust in the situation where you're taking the weight off of the skids or landing gear, and you're taking it, and the main rotor is taking or supporting the weight of the aircraft, then you're just gonna, kind of just float off, and that's not stabilized flight. We always want stabilized departures. That is for my guys that I talked to, and they asked me that question. All right, so coming back to there's a lot of math questions tonight, and one is concerning absolute value. All right, and it's very clear that we understand absolute value. Absolute value it does not care about positive and negative numbers. It's merely relating to the distance. All right. So you could possibly come up with 2 answers. For instance, let's say you get a problem where it'll say, okay, the absolute value of 6m equals 42. Well, in this situation, we can have 2 answers. All right. Now, first, what we would do is we would divide both sides by 6, and we would come up with 7, because 6 times 7, m would be equal to 7, right? But it could also be equal to -7, because it does not matter as long as the variable is within the confines of the absolute value brackets. 6 times 7 is 42, and -6 times 7 is -2, but it is within the absolute value brackets. So the solution set to this is 7 and -7. That is the solution set. All right, I will do one more, because you won't always get like the same number, because a lot of times people will be like, okay, well, the number's always going to be plus or minus. Well, that's not always true. For instance, if I have the absolute value of 7 plus p and the absolute value brackets equals 7. All right. Now, 2 situations could happen here. All right. We throw 7 to the side, all right, to the other side, right? And it would become -7. So p would be equal to 0 in that case. But if we put -14 in there, absolute value 7 plus -14, the result will be -7. But again, it is in the absolute value brackets, so it's considered a positive 7. All right, and so our solution set to this would be 0 and -14, which is right there. Long day, guys, as usual, right? All right, so the solution set is 0 and -14. So you want to be very, very careful how you handle these absolute value problems, because if you're not paying attention, they can and will get you into trouble. All right. Let's get another question going. Okay. Now, another issue that I come across from time to time is percentage problems. First off, a lot of people do not know how to, or I won't say they do not know, they just forgot. Like they've dealt with this in school. And the theory of disuse, I always say, if you don't use it, you lose it. So basically, converting fractions to decimals to percentages. All right. If we have half of something, that's 1/2. I'll start off with something easy. And then if we want to know what it is in decimal form, it's 0.5. And if we want to know the percentage, it's 50%. So I'm going to show you how to kind of convert back and forth. Let's use something like, well, how do we get this first of all? All right, let's talk about that. Well, with the 1/2, if we want to find the decimal, basically what we'll do is we'll say the 1 falls down under the house because we're going to wind up dividing, and I'm going to put 1.0. So 2 cannot, and we'll raise the decimal. Sorry, guys. So 2 can't go into 1, but 2 can go into 10. How many times? 5 times. So the answer is 0.5 in decimal form. And then if I want to change this to a percent, I'm just going to merely move the decimal place over twice, 50, and that's how we get 50%. All right. If I want to go back from the percentage to decimal to fraction, then what I'm going to do is I'm going to, so let's say 75%. All right. And basically in order to get, and use this as a baseline, all right? If you're lost on the test and you're like, wow, I forgot how to, convert, then use this as a baseline. You know that 1/2 and 0.5 and 50% are all equivalent. So you got to think, I'm going from percent back to the fraction. All right, so what happened here in reverse? We moved the decimal point 2 places. So the decimal form is 0.75. The decimal place is there. We move it over 1, 2. So we have 0.75. And then if we want to go to the fraction, we have to look at the last digit. What decimal place is it in? This is in the hundredths place. So this is the tenths place. If it was just 0.7, then we would say 7 over 10 and then reduce the fraction if that was possible. But we have 7.5, so it is in the hundredths place. So we say 75 over 100. And when we reduce this, both of these are divisible by, let's see, 5. The numerator and the denominator, we're going to divide by 5. So we get 1/15 over 20. And then we look at this again, and we divide by 5 again. And we get 3 over 4. And we can't do anything with that anymore. So 3/4 is the fractional form of 0.75. So 3/4, 0.75, and 75%. They're all equivalent. All right. So like I said, if you get lost in the test, go back to a baseline. Okay. You know that 1/2 is 0.5 and it's 50%. And as long as you do that, it'll keep you out of trouble. So that's just like different. That's a strategy that I teach because a lot of people have trouble. Another major, let me see if I got any questions in the meantime, any additional ones in the meantime, real quick. All right, I do. Keep them coming, guys. Another situation where people have problems is when they give you a question like, all right, what is 90%? All right, and you have to watch the wording. What is 90% of 130 inches? Question mark. So you have to look at what numbers are tied to the is and of, because my formula is over of equals the unknown percentage over 100%. And the is attached to 90, so it's telling you where to put it, and it is. The of part is 130, 130. And we put our equal sign, we have our unknown percentage here, and we have 100%. And all we merely need to do is cross multiply and divide. So we cross multiply the known factors. Think of this as an x. All right, and at the ends of one of the sticks of the x, you're going to have 2 known things. So this is what you multiply, the 90 and 100. But I'm not going to deal with, I'm going to multiply 9 times 1, and then I'm going to add the zeros later. So 9 times 1 is 9, and then I have 3 zeros, so that is 9,000. and then we're going to divide by 130. But all my people that have been working with me knows I'm not going to work with all that. I'm going to slash a zero, and I'm going to get the same answer if I divide 900 by 13. Okay, so we look at this. How many times, and long division, that's another lost art, because people use calculators, and on this test you're not allowed to use calculators, so you're going to have to get back into your skills that you learned early in math. So 13 does not go into 9. I'll put a 0 there. 13 will go into 90. 9 times is too much. 8 times might even be too much, but I will test 13 times 8, and it is, because 24, 104. So now I'll test 13 times 7, 2, 91. That is too big. So 13 times 6 is going to work. Run out of real estate. 18, 78. So 6 works. We'll place the 6 there. We'll put a 78 here, and we'll need to subtract. All right. I know that this is going to be 112. All right. Now 13 cannot go into 12. We're going to drop a 0. So we need to see how many times. Hold on. Why do I feel like I'm off, guys? All right. Give me a moment. 13, 96, 78. 12. We dropped a 0. And 120. 10 is too big. 13 times 9, 7, 2, 117. 69. Okay. So that can't be true. But it's alright. Because there's more than one way to kill. What do they say? There's more than one way to skin a cat. I don't know why my math came off on that one. But I know that this is not right. So, what I would do, and what you can do, if I want to know 90% of 30 inches, I can multiply 130 times 0.9. I'll get 0, 27, 1, 1. And we have 1 decimal place. So 117 is 90%. I don't know why that cross multiplication did not work. I'm going to analyze this video later, and I'm going to see why that didn't work. But I have my backup. So the is over of formula, you don't always have to use. Like I just used the 0.9. And there's always there's more than one method to approach math problems with. So, you know, I just knew like 90% of 130 was not going to be 60 something. I'll analyze and see where I made the misstep. But the thing is you got to have an idea so you can catch yourself. Like I just caught myself. I'm like, yo, it's not right. And so it didn't feel right to me. So we'll analyze that at a later date. All right. All right. Looking at some more questions, and I appreciate all you guys sending questions. But what I try to do in every live stream is I try to go with questions that we don't see a lot. And so it just, just gives viewers and subscribers another way. Sometimes radical problems can get a little crazy. And I want to touch on that because a lot of people, they see that square root symbol and they go nuts. They're like, look, I can't do this. Okay, so let's find a crazy one. Let's find a really crazy one. Oh, maybe one not so crazy. I like this one. Okay. So now, when we're looking at a square root symbol, the square root symbol is telling us if it's just a regular square root, all right, with no number on the top, because it could be a cubed root, a fourth root, a fifth root. But when we just see the regular square root symbol, there's a 2 here. That's why we call it square root. So there is a 2 there. But most math writers or people that print the books and the problems are not going to put it there. But we have to understand that there is a 2 there. All right. So for instance, if I said, okay, I want to know the square root of 45p squared. All right. So, what I like to do, or my approach to this, is deal with the number first, then deal with the variable. If you keep your structure like that, it's going to keep you out of trouble. I promise you. That's the way I always do it, and I don't do it any other way because based on the years that I've been doing math, I figured that this is the simplest way to arrive at the right answer. So, we look for our hot numbers: 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. And the result of these numbers is 4, 9, 16, 25, 36, 40, 9, 64, 81, and 100. So when I'm looking for factors to break down 45, I'm looking for one of these numbers on the right. I call them hot numbers. It's not like an official, all the trolls out there, oh, what's a hot number? That's not official. No, it's just what I call it because I feel like it's like a game show. When I'm looking at radicals and I'm like, when I find a factor. So basically, I'm looking at 1 times 45. No hot number. 1 is not a hot number. 45 is not a hot number. 2 is not going to work because that's even, that's odd. 3 could possibly work, right? 3, 1, 15. But still, no hot number over here. We don't have a 4, 9, 16, 25, 36, 49, 64, 81, or 100. 4 is not going to work. 5 times 9. Ding, 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 ding. The audience is clapping. Everybody's going nuts. Sorry, I dropped my cap. So everybody's going nuts. 5 is not a hot number, but 9 is a hot number. So 5 and 9 is the factors that we're going to use. So always put the one that breaks down first. 9 times 5 is equal to the square root of 45. Now 3 is going to come out, which means 9 is going to break down because we're essentially saying the square root of 9 times the square root of 5 is equal to the square root of 45. So we're going to get 3 root 5, okay, because the 9 breaks down. So these two come down, but this converts to a 3 because 3 times 3 is 9. 5 can't be broken down any further. So now we have to deal with the p. Again, in order to come to a final result of p squared is p times p. But since we just think of this p is going to jump out of the radical. But remember, there's a 2 up there. So that is the fare for that p. All right. Look, p, you can leave, but I'm going to need that too. I'm going to need that too, son. Sounds like somebody from the back of my oldest. So I'm going to need that p, son. So the final result is going to be 3. P is the result jumping out of the radical symbol. It's going to lose its 2. And then we will have root 5. All right, so that is the final answer. 3p root 5. All right, I'll do another one because I know people are like looking at that like, what? And I want to do another. I want to do an interesting one. All right. Now, so that p lost the 2 as a result of jumping out of the radical sign. So let's say 80p3. All right, under the square root symbol. All right. Again, we're going to work with the number first. We're looking for hot numbers. 1 times 80. 2 times 40. No hot number. 3 is not going to work. 4 times 20. Now, at this point, 4 is a hot number. But whenever we have factors that one of them could be a hot number, i.e. 4 times 5, then this is like saying the square root of 4, this one, times the square root of 4, this one, times the square root of 5. Now these two are going to break down to 2's, and 2 times 2 is 4. So 4 root 5 is basically what we're going to come up with when we solve the square root of 80. 4 root 5. Now we're going to deal with the p cubed. Again, like I said before, the p can jump out of the radical sign, but the radical symbol is like a bully. Like, yo, I'm gonna need 2, son, because that square root is a 2. So we're gonna have 4p root 5p, and that is the final answer. All right. So don't be scared of square roots. Square roots they're not that bad. The only reason why people don't like them is because they haven't dealt with a lot of them. You can Google all kinds of worksheets and stuff like that and everything, and you can work them out on your own, or you can link up with me at stemwithkino.com, and I can tutor you and show you how to do them. Or any tutor worth their weight is going to understand how to work with square roots. All right, so that is a lost art. Another thing, hold on, let me check my email, see if I got any good extra questions that are kind of different. All right. That's good, Julia. I can't wait to jump on that. All right, so I got a nice, interesting question that just came in. I want to deal with one more thing. A lot of people have issues with adding and subtracting radicals, and these show up on all the military aptitude tests. I'm telling you, you just have to be ready, and you have to be prepared for them when they come up. Now, the simple ones are just simple. For instance, I don't need that. I wrote that there for you guys. All right, now, an interesting one is all right, if I say you have 3 root 6 minus 4 root 6, they're in the same family, because this is 3 times root 6 minus 4 times root 6, but they're in the same family. It's just like saying 3a minus 4a. They're in the same family, and we're going to combine like terms. So just like this would be negative a, or it's negative 1a, but the 1 is assumed to be there, but we would see it as 1a. That's what it would be simplified as. All right. This would be negative root 6, would be the answer to this question. Negative root 6, or negative 1 times the square root of 6. It's the same thing, but this is probably the way that the answer is going to be printed out. Now that's the nice one. Let's grab an ugly one. Okay, I found one. All right, so this is an uglier one, because you're going to have to look at this and you're going to have to analyze a little bit. So negative 2 root 3 plus 3 root 27. Okay, so now we're looking at this. Now, the cool thing about this is normally when you have like the smaller square root, normally it's probably one of the factors here. So I'm thinking, and that's not the end all be all, but it's a possibility. All right. So negative 2 root 3. And 3 to me breaks down 27, the square root of 9, and the square root of 3. Told you, one of the factors possible. All right. So, okay, let's not forget my plus sign. All right. So we have negative 2 root 3 plus 3 times, this breaks down to a 3, and root 3. Now we have to multiply these. These become 9. All right. 3 times 3 is 9. 9 root 3. So now we have negative 2 root 3 plus 9 root 3. And the result is going to be 7 root 3. Final answer. 7 root 3. All right. So this is how they kind of get uglier. And I'm going to kind of dedicate more time in the live streams to square roots, because, like I said, it's a lost art. A lot of people, they hate square roots. They see them and they go nutty. They're like, oh my God, man, I hate this question. Okay. Now, the next question, shout out to Julia here in the room. Let me see. Okay. A ship at a latitude of 35 degrees north and a longitude of 30 degrees east is in the what sea? Now, what I recommend is most people do not have accurate or working knowledge of navigation. So, in the confines of this live stream, this little hour live stream, this is really like a huge, like major kind of lesson. You have to understand the world atlas, or how we use a certain coordinate system in order to find things. It's how we navigate, by air, by sea, or whatever. But I would encourage you to kind of look up the World Atlas and type in with longitude and latitude lines. There you go. World Atlas with longitude and latitude lines. If you guys could do that, that would greatly help out the mission here. All right. So, give me a moment. And I am going to click on, you click on view image. If you guys have time, or not necessarily having time, you're here, so you do have time, but look up World Atlas with longitude and latitude lines. Now, when you look at this World Atlas, and I'm looking at this now, you have the prime meridian. So let's just think of the globe, and we're looking at it from the top, from the North Pole. And just think there are 360 degrees in a circle, but 0 is called the prime meridian, and it runs through Greenwich. It's spelled Greenwich, but Greenwich is how it's pronounced. And it runs through Greenwich, England. And that's where 0 degrees starts. Okay, so we could either go 15 degrees west, or we could go 15 degrees east. All right. But at the other side is 180 degrees. So just think of a big giant protractor on the planet. All right. In the center is the North Pole. And that's where these lines run. So if we looked at the globe from a side view, we'd have the North Pole, the South Pole. The prime meridian would be running through the middle. That would represent 0 degrees. The equator would be running like this. And so for navigation purposes, when we want to find certain locations, we would mark over 15, 30, 45 degrees, whatever have you. On a flat map, it would just look like this. The prime meridian would run in the middle, and then you would have 15 degrees west of the prime meridian, 30 degrees west of because north is always the top of the map, south is always the bottom of the map, and west is the left side, and east is the right side. So you could only be going north, south, east, north, east, south, or west. I'm sorry about that, guys. When we're navigating. I told you this was long, but it's a great, great question. So, back to the question. So, what this question is saying, the ship is at a latitude of 35 degrees north and 30 degrees east. So, from the prime meridian, we're going 30 degrees east. All right. If we go to our World Atlas, 30 degrees east runs through places like Turkey, Egypt, in South Africa at 30 degrees east of the prime meridian. All right. Now, that is we established that vertical point that goes from the North Pole to the South Pole at 0 degrees longitude is the 0 point of the prime meridian. Now, we also had another coordinate, which was lost it, 35 degrees north. So if we looked at the globe from a side view and we have the equator running down, 0 degrees latitude is the equator. And so we're just going to go up 35 degrees. So it's kind of like the coordinate system. We're going to go 30 degrees east of the prime meridian and 35 degrees north. All right, so if we come up and they're asking, is this the Bering Sea, the Caribbean Sea, the Mediterranean Sea, the North Sea, or the Sea of Japan? All right, and it is the Mediterranean Sea. All right, if you just start at the equator, I would recommend you go 30 degrees to the east, which is there, and then up, and that's the Mediterranean Sea where Turkey, Greece, Syria, and all that stuff is. All right, but that was really, really a good question. And another thing that I should note is that on the one side, if we're looking at the Earth from the top, 0 degrees is the prime meridian, and on the other side, it is the international dateline. So that was an awesome question. Now, for process of elimination purposes, all right, our options were the Bering Sea, the Caribbean Sea. We know it's not the Caribbean because the Caribbean will be west of the prime meridian. The North Sea, I'm not even sure where that is. The Sea of Japan, no, it's not that far. It's not over that far enough. So you could eliminate the Caribbean and the Bering Sea. The Sea of Japan. It's not the Bering Sea because I believe that the Bering Sea is at the Bering Strait, which joins Alaska and the USSR or Mother Russia. I say Mother Russia because I like the way the Russians say it, Mother Russia. No disrespect to any Russian subscribers out there, but I like that deep Russian voice. At any rate, so for the process of elimination purposes, you can eliminate the Bering Sea, the Caribbean Sea, the Sea of Japan, and then you'd be working with the North Sea and the Mediterranean Sea. And I know that the Mediterranean Sea is like Greece, Turkey, Syria, Israel, all over there. All right. So was that clear, guys? Okay. Thanks, Julia. You said it makes much more sense. I don't know what the what was, but all right. So yeah, that was awesome. That was an awesome question. But honestly, most people have no idea, when it comes to the coordinate system and prime meridians. And about the equator. Everybody knows about the equator because that's where all the solar energy is pretty much centrally concentrated. And those are very, very hot areas or warmer areas of the Earth. So I would recommend you get a world atlas looking at latitude and longitudes and just figuring out where things are. Like, say for instance, United States is about roughly 75 to 120 degrees west of the prime meridian, and it is 30 to 40 degrees north of the equator. And it's just like you're putting a big giant protractor on the planet. So that was an amazing question, Julia. You always come up with those type of questions, which is an indication of how well you will do on this exam. I always gauge it when people are asking really, really tough questions, then the easy questions are probably not going to be a challenge because they've gone through their book. Like I tell all my guys, go through their whole book and you're not going to not know 100% of it. You may only know 50% of it or 60% of it. But, you just mark what you don't know. And then during our sessions or during the live streams, and even if you guys aren't subscribed or you're not a client of mine, this is the time where you can ask questions. And sometimes I don't understand it because you see people in the room and the people that are in the room are not asking the questions. It's like, this is free. take a picture, send it to the email, here every week. But, you know, hey, you guys figure it out. And you can just say anonymous. I won't mention your name. You know, some people are like, oh, I don't want my name mentioned. You know, and that's fine. I have no problem with that. Okay. So, thank you, Julia, for that awesome, amazing question. When you were explaining radicals is when I said what? Oh, okay. All right. Yeah, radicals are, they're kind of the upper echelon of things that people have problems with. Okay, and this thing is DVRable, so even after I do my little finger thing, you can still go back over this and you can play it and you can get your atlas and, you know, you can go through all that stuff and everything. Okay. All right. Wow. Okay. All right. Man, you guys are hitting me hard tonight. This one is concerning aviation information. And the question is, what is a VG diagram? Okay. I'd encourage everybody, especially if you are SIFT, AFOQT with an aviation interest, ASTB with an aviation interest, to follow me. You can go to Google. Everything is on Google. And you guys know that? All right. VG diagram. And you can click on any of these VG diagrams. There's one, if you scroll down a little bit, you'll see ones with letters in them on the diagram. All right. And a VG diagram is a diagram that the engineers come up with when they test fly the airplane, and they come up with these magical numbers that the pilots are not supposed to. It's called an envelope. All right. And the green and yellow are the green is the normal range of the envelope. And VG, why do they call it a VG? Because velocity versus load factor. All right. So right now you're sitting down in your chair. You have a load factor of 1 unit of gravitational pull acting on your body right now. So if you are 100 pounds, when gravity acts on your body, it's exerting 100 pounds. If you got on a scale, gravitational pull acts on your body at 9.8 meters per second squared. That is the gravitational acceleration rate. So now, sometimes when we get into flight maneuvers like turns, the weight your weight actually increases. It's called pulling G's, or gravity loading. And your weight actually increases momentarily. You could load gravity positively, or you could load it negatively. For example, have you ever been on a roller coaster? And the roller coaster is going up, 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 and then boom. And then it kind of descends. This is pulling negative gravity. Your body goes weightless, and this is why you have restraints in a roller coaster, because if they did not have restraints in a roller coaster, when you got to this point in the roller coaster, your body would be ejected. This is called inertia. Inertia is the tendency of a body to keep moving. Another example of inertia is when you're in a car, and this is why we have seatbelts, because you ever watch those crash dummy commercials, and the car, it smacks into the brick wall or something like that. And then the crash test dummy, his body just kind of wants to boom, go up, and then the airbags deflate and push the crash test dummy back. All right. So that is G loading. So whenever we operate outside of in this VG diagram, if we load up gravity at a certain speed, what's going to happen is structural damage can occur to the aircraft. And that's why we have to be mindful. We have something called VA. V just means velocity, and A is maneuvering speed, or some manufacturers will call it a turbulence penetration speed. If I maintain the speed, this means I can put the full control inputs in the aircraft, and I will not structurally damage the aircraft as long as I have the speed, as long as I am in a proper speed regime. Another interesting thing about the VG diagram is these dictate the color-coded markings on airspeed indicators. In airspeed indicators, you have a white arc, you have a green arc, you have a yellow arc, and you have a red arc. The red arc represents the V and E. A lot of V speeds tonight, guys. V and E, this is the never exceed speed. If you exceed the speed and you get in a rough air, you're probably going to cause structural damage. We refer to this as overstress, and that is correct. You are overstressing the aircraft, and you are compromising the structural integrity of the aircraft, which is a no-no. I don't want my wings coming off when I'm flying. Don't want that. This is what the VG diagram is for. It's velocity versus G loads. If you're G loading, you want to be slow. Or, otherwise it's easy to cause structural damage to the aircraft. If you have high speed, you don't want to be loading up Gs unless you have an aircraft that is structurally, say like your aerobatic aircraft, like the Blue Angels, like the F-18s, the F-16s. These planes are structurally built to load gravity and handle these speeds. They are the category would be, or the class will probably be aerobatic. All right, which if you're going to do aerobatic maneuvers, you're going to need a parachute. Yes, it does. It does apply to fixed wing, and helicopters. They go fast, and you could put it in a situation where you could structurally overload it, namely banking. Because if I bank that helicopter 60 degrees and I pull back on a cyclic or the collective, all right, right now at this point, if this helicopter, if in regular flight, before we leave the ground with fuel and everything, it is 1,000 pounds. And I'm just throwing some numbers out. When we get into the 60-degree banking situation, it's 2,000 pounds because our unit of gravity we've increased. We're G loading, all right. And so at this point, at a 60-degree banking turn, we're 2,000 pounds because at 60 degrees, the load factor is 2, which means the gravitational pull on the aircraft, the occupants in the aircraft, and everything is 2. So everything in that helicopter has doubled weight-wise. Wow, this is going fast. This hour goes fast. Okay. Wow. Time flies when you're having fun. All right. Wow. Okay. Somebody wants to know more about radicals. And this is multiplying radicals. I was probably thinking about holding this till next week, but we'll go ahead and we will jump in. This is actually, it's a tough radical question if you are not prepared to deal with radicals. But it's all right. All right. So this is going to look like Chinese to most people. Outside the parentheses, we have 3 root 3. And in parentheses, we have 2 plus the square root of 6. Now, something very interesting is going to happen. We have a whole number and we have a radical. And we're going to distribute this into the parentheses. Now, this is a situation where, like you have the whole number we're going to deal with individually, and then we're going to deal with the root 6. So when we take this situation and we multiply it with this, the only thing that applies to the 2 is the negative 3. So it will be negative 6 root 3. The root 3 can't deal with the 2. Only the whole number can deal with the 2. And then when we do this one, the negative 3 can't deal with the root 6. Only the root 3, if I can talk, can deal with the root 6. So then when we multiply this negative 3 root 3, we'll still have the negative 3, but then the radicals will be multiplied together. And then we will have 18, right? Because the square root of 3 times the square root of 6 is the square root of 18. And then negative 3 just hangs out. So in the first situation, the radical hung out, and we just multiplied negative 3 times 2 and got negative 6. And in the second case, the negative 3 was just kind of, all right, I'm going to just hang out on the side and let the radicals deal with each other. And they did, because the square root of 3 and the square root of 6 is the square root of 18. So now this comes back to your ability to break down the radical. So I see the square root of 9, which is a hot number, and the square root of 2. All right. So now we have negative 6 root 3 minus 3, and the 9 breaks down to a 3. So that's going to become negative 3 and 3 is negative 9, and then root 2. And since they're not in the same family, they really can't deal with each other. So I know it kind of looked up, but as long as you know how to handle it, my final answer is negative 6 root 3 minus 9 root 2. Okay. So, it looks like we're at the end of another live stream. I'd like to thank everybody that for coming out. If you have done 2 hours with me on, throughout the week, and you would like to come to the Google Hangout, please shoot me an email now. You already know my email if you guys are dealing with me, but I'm going to type it in anyway. Bang. All right, KenoThomas@gmail.com. So, to anybody that's new to the room, also hit the like button if you haven't hit the like button, or the dislike button. Either way, it does not matter to me, just for activity purposes. But anybody new to the room, or if you're viewing this later, I'd just like to say I'm here every week. If you have problems with the ASVAB, Armed Services Vocational Aptitude Battery, the AFOQT, the Armed Forces Officer Qualification Test, the ASTB, the Aviation Selection Test Battery, the OAR, the Officer Aptitude Rating for the United States Navy, Marine Corps, Coast Guard, or the SIFT, which is the Army Standard Instrument for flight training. I do them all, I prep for them all, and the Federal Aviation Administration exams, from private pilot all the way up to airline transport pilot, from certified flight instructor, initial to multi-engine, and aviation ground school instructor, basic to advanced and instrument as well. I've done them all. So, I mean, there's really not anything you're going to like, oh, I don't understand this, that I can't explain. I'm looking out for my people that have done at least 2 hours with me this week. And, I will do a Google Hangout with you guys if you have worked with me this week. But at any rate, I haven't even checked the email yet. When I do check the email, I'm just going to check for that. And I will get started immediately with the live stream. provided everybody meets those conditions. And if not, I will see you guys next week. So I thank you guys for watching, taking time out to watch, and feel free to just come in, ask questions about whatever test you're preparing for. This is Kino with STEMwithKino.com. Thanks for watching, and it's time for the finger thing, and see you later, guys. Bye.